Hello and welcome to my explanation video of the electronic solar tracking circuit that I used in my earlier short video of a solar tracking power gimbal. There are 4 small photovoltaic cells, 2 dual op amps, 4 double throw relays, 2 worm gear motors. The motors I used were 2 RPM and one 12-volt motorbike battery. Flashing black are the common negative wires connecting back to the battery. Flashing gray, brown, pink and green wires are the positive outputs from the PV solar cells. Flashing yellow, green, light blue and purple wires are the outputs from the dual op amps that trigger the relays to activate. Flashing red and black wires are the power from the first relays to the second relays. This avoids a potential short circuit if both, clockwise and anti-clockwise, relays are energized at the same time. This is due to a possible hysteresis effect. It takes longer for the solenoid to deactivate than it does to activate. Flashing red are the power supply wires direct from the 12-volt battery. On the schematic of the dual op amp, V positive is the power supply from the battery. V negative is connected to the negative terminal of the battery. Output A triggers the relay to send power to the 2 RPM motor to go clockwise. Output B triggers the relay to send power to the 2 RPM motor to go anti-clockwise, by reversing the polarity. If the signal from the PV cell is connected to the inverting input A on the first op amp, then it is connected to the non-inverting input B on the second op amp. If the signal from the PV cell is connected to the non-inverting input A on the first op amp, then it is connected to the inverting input B on the second op amp. It is in effect a simple logic circuit. If A is greater than B, then go clockwise. If B is greater than A, then go anti-clockwise. The 2 RPM motors will move to orientate the PV cells until A equals B, leaving the devices pointing directly at the sun. It should then remain static until the sun moves enough to activate the motors again. The circuit for left and right is exactly the same as up and down. I used Texas Instruments LF353 wide bandwidth J-FET input dual operational amplifiers which I think are no longer available. And UXL DC 5 volts coil 8-pin DPDT power relays HK19F. The main thing is to pick an op amp that has enough output to trigger the relay to activate. Thanks for watching, and if you made it this far, you should smash the like button and subscribe to the channel.